2019. Question 11 on the past paper 2019 is one of the three markers. Right, we have differences in physical and chemical properties can be used to distinguish one compound from another. The compounds extracted from orange juice include antioxidants, flavour molecules, essential oils, aroma molecules, and coloured molecules. Some examples are shown below. Using your knowledge of chemistry, comment on how the differences in physical and chemical properties can be used to distinguish between the compounds extracted from orange juice. Okay, so let's look at the clues in the question. Okay, so we are looking for the differences in physical and chemical properties and how they can be used to distinguish between them. Okay, and then they telling you that we have a whole pile of different things. We've got antioxidants, which you should also reckon are reducing agents. Oh, reducing. Oh, can't spell. Sorry, reducing. Oh dear, terrible. Flavour molecules, essential oils, that's potentially got something to do with that. Aroma molecules and coloured molecules, and we can probably do something with the colour, okay? Just as kind of standard basic things. Right, so what we're looking to do is try and see how we could distinguish between all of these different potential compounds. So, okay, for a start, let's go for a big thing you could do. We could use chromatography just to separate out different compounds. That would tell you something about their basically their mass and their charge, or their polarity, about how far they would actually move. And you could use standard banks of things to decide if their RF values were the same. Okay, just as a big potential one here. What we've then got are other ways that these behave. So anything with double bonds, okay, so double bonds will allow you to do kind of changes. Actually, I'll just go for the ChH ones, okay, because we've got a big pile of these. So we've got addition reactions that we could try with these. Okay, that could give you some information. So just whether it's saturated, unsaturated, just using bromine. Okay, we could use a straight up in terms of the oils. We could talk about solubility in water, more precisely. We could also again with the double bonds, but this time looking very specifically at our carbonyls. Okay, if we've got carbonyls here, that's not carbonyls, so that's carboxyl. Our carbonyls can be used to determine if we've got aldehydes and ketones. Okay, so we could talk about that. We also have ones that will resist any further oxidation, because here we have got full acid groups here. Where are we going? Now we've actually got an ester. This is not actually a C double bond O, just in the carbonyl group on that one. So you could talk about that. The esters we could break using hydrolysis and then testing what we've got from that. You notice this is an acid, so we could test pH. What else have we got? The colour. Since we're talking about coloured molecules is potentially here, we could use absorbance, and absorbance just in different wavelengths of light. So we are looking for you to recognise what all of these could do, or could do if they react with something else. Now, if you put an oxidising agent in, how would they behave? If you put a reducing agent, how would they behave? If you tried to put them under reflux for hydrolysis, what would they break down into? You know, all of that can help you. And yeah, it's not the nicest one of the three markers. I don't think it gives you everything that I would be looking for to give me a really clear, easy breakdown for the mark. But you should be able to pick up quite a few reasonable chemistry points, and all we're looking for is a good understanding of chemistry in terms of distinguishing between things. Okay.